Okay, why is this example about find the volume of the solid? Before I talk about volume of solid, how to find it? This is actually on page 321, volume of solid. So normally, volume of a solid. How do you find? Because when you have something like this, F, X, Y, Z, dV, right? We start when, okay, this is density. Then usually if you do this, you become a mass, right? Now how do you find volume now? You will know, this is one example here. How to find volume? Put what? F, X, Y, Z equal to 1. Then integrate this one. 1 dV become what? Okay, density times volume, right? Well, because how to find the mass? Because density times volume, right? So this becomes the volume of solid now. So we just integrate 1 over the region G. Okay, integrate 1 over the region G. You'll get the volume of the solid. Okay, this is actually this is mentioned on page 321. Okay, page 321. Okay, when f, x, y, z equal to 1, you get the volume of the G. So once understand this,
it's like you say that f, x, y, z dv is equals to mass equals to density times the volume, but then why is it like when triple integrate the 1 dv is equals to volume of solid and not the mass?
Why? Because when the density equal to 1, right?
Or area.
The density equal to 1, right? Well, 1 times the volume is actually the same as the volume, right? The mass you calculate is the same as the volume now.
Oh, okay.
If the density is 1, then density is 1 times the volume, of course, it's volume, right? The number.
Oh, it's like 1 to 1 now.
Yeah. Numerically, this answer is also the mass. If density 1, if density 1 is also the mass. So, but this numerically, this is also the volume of what you're looking for now. Okay, numerically, because if your density 1, of course, 1 times volume is the same as the mass. Okay, also the volume of the whole thing, G, right? That's why you got this thing. So this is just tell you. Okay, so this is actually 1 times volume, right? Density times volume. But density is 1 now. Then you get the value of volume is the same as the value of the mass now. Okay. So that's tell me how to handle this equation, right? Find the volume of the solid with the cylinder x squared or y squared equal to 9, vertical cylinder, between z equal to plane z equal to 1 and x plus z equal to 5. X plus y equal to 5 is a plane. Z equal to 1 is also a plane. So basically, this solid is hanging mid-air, okay, between z equal to 1 and x plus z equal to 5. So this solid is hanging in the mid-air. Okay, let's look at the picture there. There's a gap between z equal to 0 and z equal to 1. Okay, there's a gap between z equal to 0 and z equal to 1, right? So how do you find the volume of this thing? Well, we tell you that the volume of this thing of solid, right? In this case, is integration 1 dV. Okay, integration 1 dB should be the answer already. Now, how to integrate 1 dB? So let's try to use dy, dx, dz, the same again, right? So I'm going to do that. So integrate this one. Okay, 1 dz, dy, dx. Okay, so if you look at the region base, at the base, because they have a common base, which is a circle of radius 3. X squared y squared equal to 9. This is a circle of radius 3. That common base. Okay, common base, that the base all go up because of this equation x squared or y squared equal to 9. Okay, common base here. So the x from where to where, you can see, so x equal from -3 to 3. Okay, x equal -3 to 3, yeah. Then, where is the y going now? Because this equation is x squared plus y squared equal to 9. So that means that if I fix my x anywhere between -3 to 3, then the y is equal to square root of 9 minus x squared if your y is above x-axis, right? So this is plus or minus here. So if your y below x-axis, so your y is negative. If the y above x-axis, the y positive. So when the y entered the region, this is how they enter, right? From below, enter, go in. First point you get in is y equal to, okay, first point you get in is y equal to
minus square root
minus square root of 9 minus x squared. The last point you get out, okay, is here. Last point you get out is actually this one, is where y equal to square root of 9 minus x squared. Okay, so this is actually the second limit now. Okay, now after I finish already, let's look at the possible z now. Remember, this solid is hanging in the mid-air.
Z equals to 1.
Z equal to 1 is the smallest value. What is the largest value you can get?
Z is equals to
So you can say somewhere here, okay, somewhere here, you go up until you hit the surface, right? Z equal to 1, smallest value, until you hit the surface and stop. Okay, the surface is Z equal to what? 5 minus x.
Yes.
Okay, when you go up, beginning with Z equal to 1, then move all the way up until you hit the surface. At that point, the surface is Z, x plus Z equal to 5, means Z equal to 5 minus x. And this is what you integrate now. Okay, so this integration is not too bad, I think. Okay, let's go there. So I move on to solve the integration now. So this integration, I do the inner integral first. Oh, this one, actually this integration is not really too bad, not too bad, it's very difficult. Okay, it's very difficult here. I'm sure how difficult it is. It's very difficult. Alright, so let's try to figure out the integral, right? So I think I will write down the whole picture because I cannot do it one at a time because it's too broken out already. So that you want to see the whole picture, better write them. So let me copy this thing. So I want to copy this thing now. Okay, move to the next page here. So this integral we're looking at this one. Let's see why is this equal to. So x equal to minus 3 to 3. The difficult part is this one. So integrate 1 because it's z here. So z from 1 to 5 minus x, right? So you get 5 minus x minus 1. 5 minus x minus 1 is 4 minus x, right? So this actually, one step, minus 3 to 3. This y equal to minus 9 minus x squared. Y equal to 9 minus x squared now. And now this one is 5 minus x minus 1 is 4 minus x now. Okay, so until something like this, fair enough. 4 minus s dy dx. So notice that this is actually integrate by to y. Okay, put in a limit integrate by to y. Let me copy this thing to another page now. So I did selection this. This is the hard part already. So integrate 4 minus x with respect to y. Okay, 4 minus x with respect to y. So what do you get now? Minus 3 to 3. So this is 4 minus x constant y. Y equal to minus 9 minus x squared. Y equal to 9 minus x squared now. Dx now. So you put in the limit there. This is actually equal to x equal to minus 3 to 3. 4 minus x now. I think got 2 times already, right? Top minus bottom, 2 times of square root of 9 minus x squared. Okay, eventually it comes under this. X from minus 3 to 3. How do we integrate this one? Okay, so this one I'm going to split them into two integral. One is equal to x squared minus 3 to 3. Okay, this one is actually, first term is 8 square root of 9 minus x squared. The other one is minus x equal to minus 3 to 3. There will be 2x times square root of 9 minus x squared dx. Okay, I split them into two integral. 2 times 4 is 8, so 8 times square root of 9 minus x squared, and then the other one is minus 2x times integral of this one. So actually split them into two integral now. Okay, I need to evaluate these two integral. Okay, so let's try to say this is integral 1. There are two integrals, so there are two effort here. One is here, another one is here. Let's look at the second one first, right? Second one, I think it's easier to understand second one first. Why is it like that? Okay, second one, I want to do this integral. So this is actually x from -3 to 3 2x square root of 9 minus x squared. Okay, so how this graph will look like? Usually when doing the equation, it's the area under the curve, right? So area under the curve, you can just find the area under the curve. So this one, how does the curve look like? For second integral. So you can find that what is the value of x you can get? The value of x the most is x equal to 3. Why? Because if x go beyond 3, you get trouble finding square root already. Okay, square root of 9 minus x squared. So x going beyond 3, you cannot find the answer. No value already. And between -3 also. So your x only between -3 and 3. But beyond that, you cannot take square root already. 9 minus x squared. If x more than 3, you cannot take square root already. So the value of this function always between -3 and 3. Okay, so now I look at this value. I'm going to show you that this value here, this value is positive. Okay, no matter where is your x here, this value is positive. Okay, no matter where is the value of x here, this is positive. This one can be positive, negative. Okay, can be positive. This one positive. If x greater than 0, negative is x less than 0. Okay, so multiply together, you will find that if x positive, you get a curve on the right hand side, always positive. So I'm not sure how it look like. I just can now draw first. After you can check using decimal. Okay, so this is positive. The other half, if x less than 0, you have -1. It's symmetrical. Okay, I think it's not very good. Let me look at this one. More like this one. After use the decimal to check. So when you integrate over the region from -3 to 3, you have this area under the curve. This is positive area. This is negative area. And they cancel each other. So this is actually 0.
Oh.
Without doing any integration. Of course, you can do a substitution or come up with an answer, but you actually can get an answer by this kind of reasoning. The symmetrical, and in one x positive, one negative. So you can try. Let me show you the graph. If I go to decimal, then I try show you a graph, right? So let me go to decimal and show you. Okay, decimal, right? So decimal now. Decimal graph. Okay. So let me go to the graph and then show you decimal. So share with you. See the graph? Okay. So there's positive area, negative area. Does that cancel each other? the area actually the same. It's not really symmetric, it's something like this. Okay. So the graph I show you also not good because I miscalculated. I should have more carefully. Okay, the graph I show you is this, which is not correct. Why is it not correct? You can see the picture here. Because when x equal to 0, when x equal to 3, y equals 0. Okay, so this actually the graph can see here. When x equal to 3, y equals 0, right? When x equals to 0, y equals 0. When x equal to minus 3, y equals 0. The only thing is this one go this way, the other one go this way. They cancel each other. Okay, because this one, for x equal to 3, get y equals 0. For x minus 3, y equals 0. X equals 0, y equals 0. So these are 3 points, they are 0. But on the left side, the area is positive. On the right side, area is negative. So they cancel each other. Okay, this is without doing any calculation. And then answer is 0. Okay, so now I go to first one. First one, right? So I insert here without any calculation. First one is actually integral. I have, let me show you the situation again. I want to look at this integral one, okay? So situation I show you again, okay? So first of all, this is actually draw the graph of a circle. Why is it a circle? Because this is a situation y equal to x squared plus y squared equal to 9. So this is a circle here. So y equal to square root of 9 minus x squared. Okay, so this is actually, if you want to find integration means you want to find the area under the curve. Okay, where the curve area is, this is minus 3 to 3. Okay, you under minus 3. So what are the graph, right? So x equals to 3, y equals 0. X equals to minus 3, y equals to 0, right? So this is actually the circle. You want to find the area under the curve because when you do integration, you're trying to find area under the curve. So this is this area you're looking for. Okay, so how do you find the answer without any integration? Very easy one, okay? Just check out the 8 here. Minus 3 to 3 without doing any integration. Okay, this will be, this is the area under the curve is half a semicircle, right? Area of circle is pi r squared. So r is 3, so 9 pi. Okay, r is 3 now because this circle radius 3, so 9 pi here. And so half of it now, so actually 9 pi over 2.
Okay, that was easy.
Right?
Yes.
Okay, the radius is 3. Okay, so 9 pi, the area of a circle is 9 pi, right? Pi r squared. So half of the area, 9 pi over 2. Okay, so then it will give you 36, right?
Yes, 36 pi.
Okay, 36 pi. Okay. Okay, I don't make mistake, right? is semicircle is pi r square over 2, right? Yeah. Okay, so put together, so answer is together finally is 36 pi, right? Put it together. So one is integral is 36 pi, and then second one is 0. Okay, so put together, right? So I'm not sure why this one. Okay. Correct. Yeah, 36 pi, correct. I thought I was wrong. So this question, I think, is a lot of clever method in the same last question. A lot of clever method to figure out the integral. Otherwise, you'll find a lot of hard way to find the integral. Okay, this one is 0, very easy to visualize. And then first one is 36 pi, just using geometrical meaning. Okay, geometrical meaning. So this one using geometry, geometry here, where you calculate means integration, geometry calculus, then you get the answer without actually doing integration. So finally, answer is 36 pi.